Hello everyone and welcome to AltcoinXP. My name is Anthony and today in this video I'm going to give you an introduction to zero knowledge proofs and hopefully maybe see how it relates to cryptocurrency. That's where it gets complicated. I didn't research that far yet. Alright guys, so I'm going to be using a condensed example, I guess you can call it, from a paper that was written by, I don't know, I'll put the image up right here. It's called How to Explain Zero Knowledge Protocols to Your Children. So essentially we have a cave that looks like this. So this is an entrance to the cave, and it comes out and it forks right here to two paths. So these paths lead down to, they join right here, but there's a door, and this door has a secret password that opens it. And only one guy knows the password to this door that can open it. So say that guy, let's put him right here. Let's call this guy Nigel. And say that Nigel wants to convince Winston that he knows the password to this door. So what Nigel would do, Nigel would run down. So Winston would wait at the fork right here. And Nigel would go down one of the paths. It doesn't matter which one. So let's say Nigel goes down this path right here, and he'll wait right at the end or whatever. So now Winston will flip a coin and say if the coin lands on heads, Nigel must come out of this path to prove that he knows the password. But if it lands on tails, then Nigel must come out of this path. And obviously, since Winston knows that there's a secret door right here that is password protected or whatever, Nigel would come out the right door or whatever. So this is how Nigel would convince Winston that he knows the password to this door. Because obviously, if he doesn't know the password, man, I confuse myself so much. If he doesn't know the password, then he can only come out one side always. But the problem with this is there's still like, it leaves it up to chance, or there's like a 50-50 chance that that Nigel will go down this path, it'll land on tails, and he'll have to come out this other path. So the problem with that is that in order to increase certainty to Winston that it wasn't just a fluke and he actually knows the password, you have to repeat this multiple times. I guess really you only have to repeat it twice. Like watch Nigel go down this path. Or why can't you only repeat it once? Like Nigel go down this path and Winston be like, all right, then come out this path, and watch him do that. So that part like kind of confuses me. But the story goes like you have to repeat it multiple times, and the more times that you repeat this, then the more certain Winston is that Nigel knows the password. And in all this time, Nigel doesn't have to give up the password to this door. So then the paper goes on to talk about, so this scheme, like I said, you can think of all the times playing this game and flipping the coin as a compute cycle or a computation or whatever. And the way to address that, instead of just having one path, you can do something like this, where there's now multiple paths, and say Winston stands right here and Nigel goes down this one again. So there's 1, 2, 3, 4, 5, 6, 7. So say you would have a seven-sided dice. And then Winston would now roll this seven-sided dice. So instead of there just being two options, there would be 7 options. And you can repeat this, have like 100 different paths or whatever, to decrease the probability to even less. So then this would take much less compute cycles than this scheme right here. There's still one problem that I see with this that means that you can't just roll the die once. You always have to roll it twice, because what happens, say Nigel goes down path number 1 right here, and then the dice lands on path number 1. So then that doesn't verify anything. That just shows Nigel goes down path number 1, Winston rolls a 1, and he comes out path number 1. And I guess the way to solve that is to have even more paths, like I was talking about before, because the more paths that you have, the less chance the dice has of rolling a 1. Say that you have 20 paths with a 20-sided dice, then that's a 1 in 20 chance of you rolling the same path that he went down. So you guys are probably thinking now, how does this relate to cryptocurrency? And to be honest, I have no clue at all. Like, obviously, this is just a basic scheme showing that there is a way that you can prove that you have knowledge, or you can prove something is correct without revealing the answer. But I don't know how that works yet, how it relates to cryptocurrency. The path for me to take is to study Zcash, because Zcash is the first one to do that. In the next video, though, so there's interactive and non-interactive zero-knowledge proofs. This is a interactive one because the two parties have to interact, I suppose. So in the next video, we're going to be talking about the difference between interactive and non-interactive zero-knowledge proofs. Hopefully this video is long enough. But if this video is not long enough, then I guess we're going to talk about it in this video. But all right, so while I'm here, I just want to remind you guys, you can donate Bitcoin or Ethereum in the links in the description. Follow me on all social media. Subscribe to this YouTube channel for more cryptocurrency videos. 2020, I'm going to be focusing more on cryptocurrency stuff. Yeah, check the description, please. It helps me out. And like this video and share it if you can too. I need help. Hey guys, so I was just thinking another benefit of that scheme that I was talking about, well, you just saw like a couple seconds ago in the video, is that once Winston verifies that Nigel knows the password through that scheme, now Winston becomes the verifier and everyone else can trust him. Well, I guess you still have to believe that Winston is acting in good faith, but I think maybe in computer protocols or whatever, you can trust Winston. But yeah, so Winston, after verifying and witnessing Nigel knowing the password, he can go on to verify to other people without repeating the same game having to be repeated.